Okay, so for 8-7 dilations, we finally get into non-rigid transformations. Remember, rigid means does not change shape or size. Well, dilations is an enlargement or reduction of the shape based off a scale factor. So we're changing the size of the shape. Okay, so our function notation for the simple ones is just capital D, K. We have that on our transformation reference sheet. And we apply that to xy by just multiplying. All we have to do is multiply our scale factor times every point. If k is bigger than 1, it's an enlargement. If k is less than 1, it's a reduction. Okay? Now, to find the scale factor, given an image and pre-image, we divide. So we find the image length divided by the pre-image length. And I'm going to show you what I mean by that right here. Next page. Okay? For example, if I wanted to find, so this is saying we're mapping black onto blue. The blue is the dilation. So to find the scale factor here, I would do image length divided by pre-image length. 6 divided by 4 would be my scale factor. 6 divided by 4, which I can simplify to 3/2. So my scale factor from going from black to blue is 3/2. That's my scale factor. On these type of ones, I would just pick a side to count. This length is 2, and we go from 2 to 1, 2, 3, 4. Well, very clearly, if I put image over pre-image, 4/2, that's a scale factor of 2. That's how we find scale factor here. Same thing, even on these ones, I could just count, that's 1, 2, and then it goes to 1, 2, 3. So I'd want to do 3/2 would be my scale factor. And one more time, just for the heck of it, we got 1, 2, and this is 1, 2, 3, 4, 5, 6. And this from black to blue, okay? So I have to do image 2 over pre-image 6. This one is 1/3. This is a reduction from black to blue. Okay, that one's a reduction, which makes sense because my scale factor is less than 1 right there. So that's something to acknowledge for finding scale factor. Okay, now for dilations not centered at the origin, we have this crazy formula, which is at the bottom of our reference sheet right here. What this is it might give you a point that is not the origin, okay? So it won't say 0 here. It'll be at any point. It could be a letter. It could be an actual point, x comma y, and it will still give us a scale factor, just like with the k, except for it gets a little bit more complicated. Now, the great thing is we just have to plug it in this formula. Remember with my formulas, everything in black stays the same, everything in color changes. So let's look at this for an example. If I want to, this one is a dilation centered at J, so it's not centered at the origin. Actually, let me show you one centered at the origin real quick. When it's centered at the origin, all we have to do is multiply 2 times every point. Just 2 times x, 2 times y. So if my z is at -2, 1, my z prime, after a scale factor of 2, will just be at -4, 2. Okay? All I'm doing is multiplying by 2. It is that simple for when it's centered at the origin, okay? When it's just the basic capital D with one number right here, it's so easy. I don't even need to spend much time on it. You just take every point and multiply by that. So on this one, it's multiplying, and the shape gets bigger. Super duper easy. For when it's not at the origin, so we got this more complicated one here. See, we have a D, but it's not just a scale factor. It also gives us the point J. So we take this xy and we plug it into the formula. The 1/2, the 2, and the 4. Okay. Where we get 2 and 4 from is from the points of J is at -2, -4. And our formula right here tells us x minus h, y minus k. That's the point j in this situation, okay? So when I do x minus -2, it turns to +2, and y minus -4 turns to +4. They reduce the formula here, and then I'm going to take every single one of my points and put them into that formula for my new coordinates, okay? For more details about how to dilate at points not centered at the origin, I would highly suggest watching this video on Savas, example problem 4, determining the image of a dilation not centered at the origin. The video walks through this really step by step if I lost you in the quick overview I did. But this is only a few of the problems that are not centered at the origin, okay? Most of them are. Most of them are as easy as, hey, just multiply every x and y by 2. Or this one is saying composing. It says it wants us to do a dilation with scale factor 1. That means nothing. It means we're keeping the same shape. I don't know why they put this one in here as an example problem, but saying dilate and then translate 4 units down. So really all we're doing is translating it 4 units down. So that's just in general how we find a scale factor, how we apply a scale factor, and how we can do it points not centered at the origin. And there's more detail here if you want to pause and read about that. But in general, that's what 8-7 dilations is all about.